In the last lecture, we had derived the expression for force exerted by a flowing fluid on the bent pipe. Now, on that expression, we are going to solve one problem. See here, the problem I have taken a 45-degree reducing bend. This bend is 45-degree reducing, which makes an angle of theta. That angle theta is 45 degree, and it is connected in a pipeline. The diameters at the inlet, mean diameter at here, is 600 mm, and diameter at outlet is 300 mm. Then we are going to find out the force exerted by a water. From through this pipe, water is flowing. So we have to find out the force exerted on the bend if intensity of pressure at the inlet is 8.829 Newton per centimeter square and rate of flow is 600 liter per second. As given data, this is the diagram. Here the force P1A1 is act, which is the pressure force at inlet. Here the pressure force at outlet. At inlet the velocity is V1. Outlet the velocity is V2. As it is a 45-degree bend, so this will be resolved in two components. One is V2 cos theta, then V2 sin theta. Similarly, the pressure force at outlet again resolve into two component, that is P2A2 cos theta and P2A2 sin theta. According to given data, first of all find out the area at inlet. A1 is equal to pi by 4 d square. Diameter at the inlet is given 600 millimeter. I am going to convert this into meter. So we'll get the area at the inlet after calculating 0.2827. Okay, then find out the area at outlet. So area at outlet pi by 4, diameter at outlet is 0.3 meter. After converting into meter, it comes 0.3 meter, and the area will come here. Here we got the area. Here 0.07068. Okay, after finding out the areas, we are going to find out the velocity at inlet and velocity at outlet. Okay, here we got the area of cross section 0.07068 meter square. The rate of flow is given, that is discharge 600 liter per second. You have to convert it into meter cube. So 600 upon 1000, it will come 0.6 meter cube per second. So discharge Q is 0.6 meter cube per second. We know the areas, we know the discharge. From this, easily we can find out the velocity at the inlet and velocity at the outlet. So velocity at inlet is equal to Q upon A1. Q is 0.6, then area is 0.2827. This will comes 0. This will come 2.122 meter per second. Then find out the velocity at outlet. So discharge upon area of cross section at outlet, that is at section 2. So 0.6 upon area is 0.07068. So the value here we got 8.488 meter per second. Then next step is, here pressure at the inlet already known to us. That pressure is P1 is equal to 8.829 Newton per centimeter square. So pressure at inlet 8.829 Newton per centimeter square. But this Newton per centimeter square you have to bring in the same unit, that is in meter. For that I am going to convert this in Newton per meter square. For the conversion you have to multiply with 10 raised to 4, then it comes Newton per meter square. And we don't know the pressure at the outlet. To finding out this pressure at the outlet, here we are going to apply the Bernoulli's equation at section 1 and 2. So the Bernoulli's equation at section 1 is P1 upon rho g plus V1 square upon 2g plus Z1 is equal to P2 upon rho g plus V2 square upon 2g plus Z2. As the pipe is horizontal, so Z1 is equal to Z2, because the pipe horizontal means the bottom line is same. So now the equation becomes P1 upon rho g plus V1 square upon 2g, that should be equal to P2 upon rho g plus V2 square upon 2g. In this equation all values are known to us, only we have to find out the pressure at the outlet. So now keep the values in this equation. We know the P1 is equal to 8.829 into 10 raised to 4 upon rho, that is nothing but density. So density is 1000 into 9.81 value of G plus V1 square. V1 is 2.122 square upon 2 into 9.81 is equal to P2 upon rho g plus V2 square. V2 square is 8.488 square upon 2 into 9.81. So I will take P2 upon rho g in this side and calculate all the values. After calculating the values, I will got the P2 upon rho g is 5.5575 meter of water. So now find out P2, that is pressure at the outlet. For that you have to multiply with this 5.5575 into rho is 1000 into 9.81, and this value will come 5.45 10 raised to 4. Okay, so this is the pressure, that will be Newton per meter square. Now as per the force exerted by the water on the bend along the x direction, as we know that along the x direction the force exerted along the x direction, so Fx is equal to rho Q V1 minus V2 cos theta plus P1 A1 minus P2 A2 cos theta. So now put the value of Fx is equal to rho is 1000 into Q is equal to 0.6, V1 is equal to 2.122 minus V2 is equal to 8.488 cos 45 plus P1 is equal to 8.829 into 10 raised to 4 into A1. A1 is equal to, so Fx is equal to rho is 1000 into Q is equal to 0.6. V1 is equal to 2.122 minus 8.488 cos 45 plus P1 8.829 into 10 raised to 4 into A1, area of cross section at section 12827 minus P2. P2 is equal to 5.45 into 10 raised to 4 into area. Area is equal to 0.07068 cos 45. So Fx is equal to, now the force exerted along the y direction, that is Fy, and this is given by the expression, that is Fy is equal to rho Q minus V2 sin theta minus P2 A2 sin theta. Now I am going to put the values, that is 1000 into 0.6, V2 velocity at this section minus 8.488 sin 45 minus P2 5.45 into 10 raised to 4 into area of cross section at the second section, that area of cross section is 0.07068 into sin 45. Then here we got, after calculating, we got the value as minus 6322.2 Newton. So this minus sign indicates that here we assumed that the force along the y direction acting in the upward, but it is in downward. Negative indicates, its negative sign indicates that it is in downward direction. So now we know the force exerted along x direction and the force exerted along the y direction. Now the next step is to find out the resultant. So resultant R is equal to f of x square plus f of y square. So the force along the horizontal direction plus force square plus force along the vertical direction. So value of Fx is 19911.4 its square plus 6322.2 square. After calculating, here I got the value of resultant is 20890 Newton. This is the resultant force. Now this resultant force makes how much degree of angle with the horizontal. So we have to find out that also. So from this formula, theta is equal to tan inverse of Fy upon tan inverse of Fy upon Fx. Now I will put the values here. Fy is equal to 6.6322.2 upon 19911.4. So after calculating, here I got the value of theta is 17 degree and 36 minute. Here initially we assume that these are the direction of Fx and Fy, but here the Fy value got the negative, so the direction of resultant is in this way, Fx here in this direction and Fy negative, so in this direction, and the theta makes an angle theta here, and this is the resultant.